Hello students, today we start with question number 7. The question is prove that the area of an equilateral triangle described on a side of a square is equal to the half of the area of the equilateral triangle described on one of its diagonal. That means first we need to draw a square. This is a square ABCD. We know the properties of square. All the sides are equal. And another thing here is on the side of the square there is a triangle, but is equilateral triangle. That means on one of its side we draw an equilateral triangle, and on the one of its diagonal we draw another equilateral triangle. These are the two equilateral triangles. One is BCCE and another is BDF. Both are equilateral triangles, and the property of equilateral triangle is all the sides are equal or the angles are equal. तो अगर हमें इन दोनों को सिमिलर करना है, इस पे ये इनके नाम जो हम लेते हैं इसको हम रैंडमली ले सकते हैं, क्योंकि इसके सारे साइड्स ऑलरेडी इक्वल होते हैं और आल एंगल्स इक्वल होते हैं, तो इसके कॉरस्पॉन्डिंग पार्ट्स पे कोई फ़र्क नहीं पड़ेगा. If we are talking about the square, we know if all the sides are equal, if we consider this side as x, then the measure of its diagonal is always equal to root 2 times the side. Root 2 times the side is the length of each diagonal, and this is an equilateral triangle. It means that each side is root 2 times the side, and this is an equilateral triangle. If this is the side, then each side is equal to the square side of the square. The question here is we need to show that the area of the equilateral triangle described on the side, जो साइड पे एक स्क्वायर बन इक्विलेटरल ट्रायंगल बना है, इसका एरिया जो होगा वो हाफ होगा of the area of this equilateral triangle described on the diagonal. So what is given here? Given square ABCD with two equilateral triangles, triangle BCE and triangle FDB described on BC and DB respectively. To prove, हमें दिखाना है एरिया ऑफ एन इक्विलेटरल ट्रायंगल डिस्क्राइब्ड ऑन द साइड, जो साइड पे ट्रायंगल होगा उसका एरिया, मतलब एरिया ऑफ द ट्रायंगल BCE is equal to the area of an equilateral triangle described. Half of the area of an is equal to the half of an area of the equilateral triangle described on its diagonal. उस ट्रायंगल के दूसरे एरिया के हाफ के बराबर होगा. दैट मीन्स हाफ ऑफ एरिया ऑफ ट्रायंगल FDB, or we can write area of triangle BCE over area of triangle FDB. हमें दिखाना है वो 1/2 होगा. Proof. Here we need to find the ratio of the two triangles, and that is equal to half. The ratio is 1/2. The two triangles are equilateral triangles, and both the triangles are equilateral means both are similar. तो अगर दोनों triangles similar है तो हम apply कर सकते हैं theorem को, and the statement of the theorem is if the two triangles are similar, then the area of the then the ratio of the area of the two similar triangles is equal to the ratio of the square of their corresponding sides. इसे हमने 2-3 क्वेश्चन में, इवन 6 क्वेश्चंस में अभी तक यूज़ किया है इस थ्योरम को. सो वी रिपीट द सेम. सिंस ट्रायंगल BCE जो होगा वो सिमिलर होगा ट्रायंगल FDB को, क्योंकि बोथ आर इक्विलेटरल ट्रायंगल्स. सो वी यूज द थ्योरम इम्प्लाइज अगर दो ट्रायंगल सिमिलर है तो उनके रेशोज एरिया ऑफ ट्रायंगल BCE और एरिया ऑफ ट्रायंगल FDB होगा इक्वल टू square of the sides of ratio, square of the ratio of the sides of the both triangles. That means db square, sorry, I'm talking about bc, so bc upon db whole square. मैं इन्हीं दो साइड्स को क्यों लेता हूँ? बिकॉज इन दोनों में जो कंडीशन है, दिस इज मेड ऑफ √2 टाइम्स दिस साइड, सो मैं इन्हीं दो साइड्स को ले रहा हूँ. ठीक. implies area of triangle BC over area of triangle FDB will be equal to BC square upon, what is DB here? That is under √2 times the side is what? That is BC. We can write this in this manner. So again we can write this as BC square upon √2 square will become 2, and BC square, as it is BC square, cancels with this thing, implies area of triangle BCE over area of triangle FDB will be equal to 1 upon 2, which proves the result. Hope you understand the question.